Math 2312, Chapter 1, Functions, Section 1, Functions and Function Notation, Video 7, From Equations to Functions. In a lot of real life and physical phenomena, there are equations relating variables representing certain quantities. You may have seen some of these in some science or chemistry or biology or physics classes. For example, you might have seen the equation force equals mass times acceleration. Or in chemistry, you might have seen this equation, PV equals nRT, and I can't remember if the R is capitalized or not. Those are equations containing, well, in this case, more than two variables. And in an equation like this, you might ask yourself, well, if I know the values of N, R, T, and V, can I figure out what P equals? Or if I know the, and I believe T is capitalized in this equation, but let's not be nitpicky. Or you could say, if I know P, V, N, and R, can I calculate what T equals? When you're doing things like that, what you're asking is one variable a function of the other? For example, is T a function of P, V, N, and R? Meaning, if you give me values for P, V, N, and R, can I find a unique value for T? Anytime you take an equation, you can ask yourself, is one variable a function of the other? Meaning, if you give me the value of one variable, must it determine a unique value for another variable? We're going to take a look at this, but only in the context of two variables. Of course, it is possible to have more than two variables, but we won't be going beyond that, beyond two variables in this class. For example, let's consider the equation 3x plus 2y equals 12. And see if we can write y as a function of x and write x as a function of y. Let's start with the first question. Write y as a function of x. What this is asking is, actually it's telling us to do something, but the implication is, if you give me a value for x, will it determine a unique value for y? Remember what makes a function a function. Every element of the domain is paired with a unique value in the range. Now, who you call the domain and range is arbitrary. For now, let's say domain are the x values. If we have a value for x, does it determine a unique value for y? Well, we can find out by trying to solve this equation for y. In general, when you're asked to write y as a function of x, or in general, write one variable as a function of the other, what you're really being asked to do is to solve for, in this case, solve for y. I'm trying to answer the question, if you give me a value of x, can I figure out what y equals? So I want this equation to say y equals. Making this equation say y equals is pretty, I don't want to say it's trivial, but it is straightforward. I can isolate the y in two steps. Number one, I can subtract the 3x from both sides. That marker's garbage. Adios, marker. Ooh, I missed. How did I miss that? It was only like 8 feet away. If I wanted to solve this for y, the first thing I could do is subtract 3x from both sides. Now be careful. When I write 12 minus 3x, I can't do a thing with it. They're not like terms. The 3x's on the left would cancel, leaving 2y equals, I can write either 12 minus 3x or negative 3x plus 12. I'm going to write it as negative 3x plus 12 just because I like my equations of lines in slope-intercept form, something we'll talk about more in detail later. This still doesn't say y equals, but if I divide everything by 2, and I do mean everything, if I divide the left by 2, it cancels the 2. If I divide the right by 2, I can't just cancel the 2 with the 12. Remember, you can only reduce parts of multiplication problems, and this 12 is part of an addition problem. But you can think of splitting this into two individual fractions, each with a denominator of 2. The first fraction would just be negative 3 halves x. But the second fraction would be 12 over 2, which is 6. I've solved for y. This shows me that if I pick a single value for x, I'm going to get a single value for y. Which means the 3 dot, I don't think I've shown you all the 3 dot triangle. I might have in a previous video. But if you ever see a math teacher or a math student or a math person draw a 3 dot triangle, it is a symbol for the word therefore. It usually means you're about to draw a conclusion or answer a question. Therefore, the function I'm looking for is f of x equals negative 3 halves x plus 6. Yes, I wrote y as a function of x. This is the function that answers the question, what does y equal if you give me an x value? But can we do it the other way around? Can we write x as a function of y? Well, to write x as a function of y means I want an equation that answers what does x equal if you give me a value for y. And if I want to know what x equals, I need to make this say x equals, which means I need to solve for x. So in other words, we're going to solve for x. Well, we would pretty much do the exact same moves but with a different goal in mind. If we're going to solve for x, then we want to start getting it by itself. So we would start by subtracting the 2y from both sides. If I subtracted 2y from both sides, it would show up on the right side as a negative 2y, but the 12 would still be positive because I didn't move it. And then to finish isolating the x, I would divide everything by 3. And again, I can't really reduce the 12 by 3 as long as I have one giant fraction. You can't reduce parts of addition problems, but I can think of separating this into two fractions, the first of which would be negative 2/3 y. The second of which would be 12/3, but 12/3 would reduce into 4. I've solved for x. If you give me a value for y and I substitute it here, it will give me a unique value for x. So x is a function of y. Therefore, we can say something like f of y is equal to negative 2/3 y plus 4. I guess if I had to summarize the point I'm trying to make, if you're trying to write one variable as a function of the other, then you solve for the first variable. If you want to write y as a function of x, you solve for y. If you want to write x as a function of y, you solve for x. In the second equation, there aren't even any x's and y's. There's a p and there's a q. But we can still ask the question, can we write one variable as a function of the other? For example, if we have p plus q squared is equal to 5, can we write p as a function of q? Well, to do this, we would have to solve for p, or at least try to solve for p. And solving for p here is pretty easy. All I would have to do is subtract the q squared to the other side, and we would get p equals negative q squared plus 5. Or you could write 5 minus q squared, whichever one looks prettier to you. And tomato, tomato, whichever one floats your boat. Therefore, we can write p as a function of q, because think about it. If you pick a value for q and substitute it, square it, stick a negative on it, and then add 5, or equivalently, stick in a number for q, square it, and subtract the result from 5, it's going to give me one single answer. So yes, p is a function of q, and we can write something like, I don't know, h of q, because the name of the function is irrelevant, is equal to negative q squared plus 5. Or you could say 5 minus q squared. Give me a number, I'll do this to it, and it'll give me a unique value for p. Now, can we write q as a function of p? Well, to answer that, we need to try to solve for q. But remember, this isn't just a game of solving for something. It's a game of also asking the question, when I do this, will it produce one unique value at a time? If I solve for q, I'm going to have to do two moves. The first move is to subtract the p over and write q squared equals 5 minus p. Or q squared equals negative p plus 5. But then we have to take the square root of both sides. And do you remember what I warned you about in the previous video in this series? If you take the square root of both sides of an equation, which I just did, then you need to put a plus minus on one side. We'll put it on the right side here in front of the square root of 5 minus p. Does that represent q as a function of p? Well, to be a function of p, that means if I pick one value of p, it will give me a unique value for q, one value for q. That won't happen here because of the plus minus. For example, if p equals 1, 5 minus 1 is 4, the square root of 4 is 2, then I stick a plus minus on it. So when p equals 1, q simultaneously equals 2 and negative 2. But to be a function, it can't be two outputs for one input. It can't be two range values for one domain value. This is not a function. Q is not a function of p because of that plus minus. Remember, a function can only produce one output at a time. So if I wrote something like f of p equals equals plus or minus the square root of 5 minus p, this gives me two answers at once, not one answer, because of the plus minus. So we can't do that one, but we can do the other ones. So in short, in closing, if you have an equation and you want to write one variable as a function of another, you solve for that first variable. If it's a function, then you can use function notation to represent it.